Here's our key for assignment number 32. We are given the graph of g, and then we are told that f is a function such that f of x is equal to the integral from -3 to x of g of t dt. So based off of our knowledge right now, that we know that not only is this the graph of g, but this is also the graph of f prime. That's going to come into play in a moment, but for starters, number 1 says find f of 1, f prime of 1, and f double prime of 1, or state that the value does not exist. So to get f of 1, that's going to be the integral. We're going to plug 1 right into here and here. The integral from -3 to 1 of g of t dt. So if we go up to our function, that means we're finding the area under the curve from -3 to 1. Well, here's negative. I guess technically we're finding the area above the curve, between the curve and the x-axis. -3 to 1 is that semicircle right there. So the semicircle, the area is pi r squared over 2. All right. Now our radius is necessary. Here's the center of that semicircle, so we're going 2 units out. So r is equal to 2. All right. So pi r squared, that means we have 4 pi. This is going to be equal to 4 pi. But we have to divide that by 2 because it's a semicircle, not a circle. So pi r squared over 2. And that region is located below the x-axis, which means that it will be negative. All right, so we have -4 pi over 2, or if you prefer, you could write -2 pi. Next up, we have f prime of 1. So we know that this is the graph of f prime, so we just need to evaluate this function when x is 1. Now, right here we see that when the function when x is 1, the function's value is 0. So very quickly, f prime of 1 is equal to 0. And then finally, we need f double prime of 1. So we're going to go back to that same spot, and we want the derivative's value right here. All right, the second derivative's value. Well, the second derivative is the derivative of what we have here, the first derivative of f. So what's going on with the derivative at this point? Well, hopefully your spidey sense is kicking into gear, and you say, wait a minute, there is a cusp right here, or corner if you prefer. All right, and the derivative does not exist at those values. All right, so f double prime of 1 does not exist. All right, and again, the reason why, the unofficial reason why is because it's a cusp. The official reason why is because the limit of the slopes coming from the left is not the same as the limit of the slopes coming from the right. All right, now with number 2, we need to place f of -5, f of -3, f of 2, and f of 5 in order from least to greatest. All right, so let's start with f of -5. That's the integral, just like we did up here for 1. That would be the integral from -3 to -5 of g of t dt. However, the bounds need to be swapped because we want our smaller number down below. So we have the opposite of the integral from -5 to -3 of g of t dt. So we're going from -5 to -3. That is this semicircle right here, which has a radius of 1. All right, r is equal to 1. So we have pi r squared, or pi, because r is 1. So pi divided by 2 because it's a semicircle. So this is equal to pi over 2, but again, keep in mind we have our negative sign, so it's actually equal to -pi over 2. Now we need f of -3. That's real easy. We see that we have no change in our bounds, which means that integral is equal to 0. Next up is f of 2. So that's the integral from -3 to 2 of g of t dt. So -3 to 2. So -3 to 1 is this semicircle, which you've already found, and then we just need to bring in our triangle. All right, the triangle has a base of 1 and a height of 2, so the area of this triangle is 1/2 base times height, or 1 unit. All right, so again, we're looking at 1/2, the base, which is 1, and the height, which is 2. That equals 1. So what's our answer? Well, we know that to get from -3 to 1, it's -2 pi. And then we just got to bring in the triangle as well. That triangle has an area of 1, so plus 1. All right, and then the last one we had to find was f of 5. So that is the integral from -3 to 5 of g of t dt. All right, so we already have what it takes to get to 2. Now we just have to worry about going from 2 all the way to 5. All right, so change colors here. We have two triangles to deal with. We have this triangle and we have that triangle. This triangle right here, 1/2, the base and the height are both 2. So that is an area of 2. And then this triangle right here, the base and the height are both 1. And again, it's below the x-axis, so it's going to be negative, so we're looking at -1/2. All right, so back here, f of 5, we have to take into account the -2 pi plus 1, which we got just to get up to 2, f of 2. Now we bring in the remaining parts from 2 to 5, so we have to add 2, and we have to subtract 1/2. So plus 2 minus 1/2, and 1 plus 2 is 3, minus 1/2 is 2.5, so this is actually -2 pi plus 2.5. All right, so we have 4 values. Here's 1, here's 2, here's 3, and here's 4. And we have to put them in order from least to greatest. All right, well, -2 pi, pi is like 3. -2 pi is like -6. -6 here and also here. -6 plus 1 is -5. -6 plus 2.5 is like -3.5. -5 is smaller than that. This is also negative. Again, if pi is 3, this is 3 divided by 2, or 1.5, so -1.5. So we have about -5, and about -3.5, and about -1.5, and that's obviously 0. So we're going in order from least to greatest, so the least would be our -5, so it's f of 2 is first, and then f of 5 is next, and then f of -5 is after that, and our last and largest value is f of -3. That's our order from least to greatest.